All right, welcome back. Day two of Math 3 Module 1 is kind of a refresher of functions. And then we add one small little element to it. If you remember back in the day, a function is a relation from a set of endpoints to a set of outputs where each input is related to exactly one output. You guys probably remember it more being for every input there's exactly one output. With that in mind, now we're going to talk about this concept of we have a function, right? But then what is a one-to-one function? And a one-to-one function is a function if any two different inputs, right, in the domain correspond to two different outputs in the range. That is, if x1 and x2 are two different inputs of a function, then f is one-to-one if f of x of 1 is not equal to f of x of 2, which means the y values do not repeat. So when we look here at figures 6 and 7, if I look here, right, every x value is paired up with one y value. Okay, therefore we would say this is 1-to-1. All right, because if we work it backwards, each y value only has one corresponding input. When we look at for figure 7, right, if I look at this 11, you see how I have this input goes to that 11 and this input goes to that 11. This means that is not 1-to-1. Okay, it's very important to kind of understand that. So if you look at the mapping diagram down below here, what you'll see is this function is 1-to-1 because each input is paired up with one y value, okay, or output value. Now letter B here, if I look, this x1 is paired up to y1, this x2 is also paired up to y1. Therefore, this is not 1-to-1, okay, because this y value has two different inputs coming into it. And remember, this cannot be 1-to-1 because it's not a function in general, because this input has two different outputs, which does not follow the rule of a function. Okay? So example A, all right, determine if the following functions are 1-to-1. So in letter A, if I look, this 38 has two different inputs going into it, which means right away this is not 1-to-1. But if I look at the next one, I'm going to look at the y values, right? First, I have to make sure it's a function. Do I have any repeating x values? No. But if I look at the y values, none of them repeat, which means every output has basically one input. Okay, so this would be 1-to-1. Now, if we're not given a mapping diagram, if you remember the test for a function, the graph of a function back in the day, we used the vertical line test. Well, to test if a function is 1-to-1, we use the horizontal line test. If every horizontal line intersects the graph of a function in at most one point, then that function is 1-to-1. Okay, so if I look at this kind of parabola in a way, this horizontal line intersects the graph 2 times, so that would not be 1-to-1. So when we look at example 1 here, determine if f of x equals x squared is 1-to-1. If I were to graph this function, you got to remember that this function is a parabola, and it would look like this. Would this graph pass the horizontal line test? And the answer is no. So this is not 1-to-1. Because if you look, this y value and this y value have two different x values. Now example 2, if you were to graph this in your calculator, f of x equals x to the third, it would look something like this. And if I draw all of my potential horizontal lines, do any of them intersect this graph more than once? No. Therefore, this is 1 to 1. It passes the horizontal line test. Okay? So, right away, do me a favor and go and complete the homework and check your